Hello viewers, today we are going to be talking about the X-ray spectrum. To begin, there are two kinds of X-ray radiations, which are BREMSSTRAHLUNG radiation and characteristic radiation. X-ray radiations are emitted when the target of an X-ray tube is struck by energetic electrons. So, what is BREMSSTRAHLUNG? BREMSSTRAHLUNG is the electromagnetic radiation produced when a charged particle is decelerated and deflected by another charged particle, typically an electron by an atomic nucleus. In BREMSSTRAHLUNG radiation, the moving particle loses kinetic energy when it electromagnetically interacts with nuclei and is converted into radiation, thus satisfying the law of conservation of energy. In comparison, characteristic radiation is formed during the electron transition processes that occur when outer shell electrons fill a vacancy in the inner shell of an atom, releasing X-rays in a pattern that is characteristic to each element. Each element has a unique set of energy levels, and thus the transition from higher to lower energy levels produces X-rays with frequencies that are characteristic to each element. Now, if we look at the spectrum of an X-ray tube, it normally has a broad lump due to this BREMSSTRAHLUNG emission. Whenever the tube voltage is high enough, some strong peaks can be seen due to the characteristic radiation of emission from the target material. Next, there are two types of X-ray spectrum, which are the continuous spectrum and the characteristic spectrum. Continuous spectrum results from BREMSSTRAHLUNG during rapid deceleration of the electrons. The figure shows the variation of intensity of continuous X-rays. The intensity increases rapidly to a maximum and then decreases, with no sharp limit. When tube voltage is raised, the intensity of all wavelengths increases, and the position of the maximum shift to shorter wavelengths. The characteristic spectrum is the result of emitted characteristic radiation when an electron and atom makes a transition from a high-energy state to a low-energy state to fill the vacancy. When the voltage on an X-ray tube is raised above a certain critical value, sharp intensity maxima appear at certain wavelengths, superimposed on the continuous spectrum. Since they are narrow and their wavelengths are characteristic of the target metal used, they are called characteristic lines. These lines fall into several sets in the order of increasing energy, referred to as K, L, M, etc. All the lines together form the characteristic spectrum of the metal used as the target. When electrons bombard the target with sufficient kinetic energy, an electron is knocked out of the K shell, leaving the atom in an excited, high-energy state. If the K shell is filled with an electron falling from L shell, the energy released is in the form of K-alpha radiation. Similarly, an electron falling from M shell gives rise to K-beta radiation. In closing, this is the list of our references. That is all from us. Thank you.